Hey guys, in this video we're going to be starting target B, which is being able to solve an equation using rational exponents. So, kind of a quick review. Target 1Z.1, in this whole video we're going to be reviewing the idea of being able to solve equations by applying the rules of equality to isolate the variable. So this should be somewhat familiar to you, but we wanted to make sure we reviewed it before we started in target B. So, what does it mean to solve an equation? Well, solving an equation means to isolate the variable if the variable is isolated, it is alone on its side of the equal sign. Alright, so what does it mean to solve an equation? Well, solving an equation means to isolate the variable. If the variable is isolated, it is alone on its side of the equal sign. Next vocab, is in inverse operations. So inverse operations are opposites. So inverse operations are opposites. So if you are adding something, so if we are adding something, what is the opposite of that? Well, the opposite would be subtraction, right? If you are multiplying, what is the opposite? Well, that would be division. So whatever operation is taking place, you just have to go ahead and do the opposite of it. Alright, so kind of some steps of solving our equations here would be step 1, locate that variable. Where is the variable? On what side of the equal sign is it? Step 2, use the inverse operations on both sides of the equation. Follow the opposite orders of the operation. So remember, kind of orders of operation, subtraction, addition, division, multiplication, exponents, and parentheses, right? Simplify and repeat as necessary until our variable is isolated. So looking at our first example, we have x plus 13 equals 19. So what I like to do, kind of just to help me make sure that everything is on the side that it is I kind of draw this dotted line where my equal sign is, so I know it's on the left and I know it's on the right. Locate my variable. Well, x is right there. I need it to be on its own on that side. So that plus 13 needs to move over to the other side. And the way that we do that is we use our inverse operations. If I am adding 13, the opposite, that inverse operation, is subtracting 13. And whatever I do to one side of the equal sign, I must do to the other. So, on my left side, I have x. My positive 13 minus 13 is 0. Bring down my equal sign. 19 minus 13 is 6. So therefore, my answer for x is x equals 6 because x is now by itself. Alright, example 2. I have 46 equals y minus 20. So again, I'm going to draw that little dotted line so I know it's on the left and right. I want to isolate my variable. So I see that minus 20 there. Has to move over to the other side, so I have to do the opposite operation. Since I'm subtracting 20, the opposite would be to add 20. And whatever I do to one side, I have to do to the other side. So right side, I have 46 plus 20, which is 66. Bring down my equal sign. Bring down my y. That negative 20 plus 20 is 0. So my final answer here would just be y equals 66. Looking at example 3, we have 22 equals f divided by 6. So again, don't get afraid with those fractions. That little bar there means divide, right? So if I am currently dividing by 6, what is the opposite of dividing by 6? Well, we need to multiply by 6. I don't know why, my God. Multiply by 6. And whatever I do to one side, I have to do to the other side. So therefore, 22 times 6 is 132. Bring down my equal sign. Since I was dividing by 6 and multiplying by 6, the only thing I have left on my right side is f. So therefore, f equals 132. Let's kind of see another division 1. If I have 3k equals 126, well, what operation is currently going on? I am multiplying 3 times k. What's the opposite of multiplication? Division. So I need to divide by 3. And again, whatever I do to one side, I have to do to the other side. My 3 divided by 3 becomes 1. So I'm just left with 1. Okay? 126 divided by 3 is 42. I never really see that coefficient in front of the k, so I can write k equals 42. Right, go ahead and flip it over to the next page, and we're going to look at multi-step equations. So when we are adding multi-step equations, you still follow those same orders of operations, right? Addition and subtraction first, then multiplication and division, exponents, parentheses, right? You have to do them backwards. So I would kind of put that up there for yourself. Remember that addition or subtraction comes first. Okay? So, looking at example number 5, I'm going to go ahead and bring my dotted line down. So addition and subtraction first. I know my variable is right here. I need to isolate. So I have to start doing the opposite operations. If I'm adding 3 on the left, I have to subtract 3 on both sides. Bring down my 10x. Positive 3 minus 3. That becomes 0. My equal sign. And 33 minus 3 is 30. Alright, I'm still not done yet because my variable is not by itself. If I have 10 times x, the opposite operation is to divide it, right? If I'm multiplying it, the opposite is to divide. And whatever I do to one side, I must do to the other side. So 10 divided by 10 is 1. I have my x there. 30 divided by 10 is 3. I typically don't need that coefficient of a 1, so my final answer is x equals 3. Example number 6, bring a little dotted line there. Again, I know my variable is right there for an x. I need to isolate it. So if I'm subtracting 8, because I have to do addition and subtraction first, the opposite of subtracting 8 is adding 8. So 5x minus negative 8 plus 8 is 0. Right, that drops from 0. 32 plus 8 is 40. Have to do the opposite operation here. So 5 times x, the opposite operation is to divide. So I need to divide by whatever is attached to that x, which is 5. Whatever I do to one side, I have to do to the other. 5 divided by 5 is 1. X on the left, 40 divided by 5 is 8. I typically don't see that coefficient there, so my final answer is x equals 8. The last two examples are whenever you have a variable on both sides. The one thing to remember before you even get started is to bring all your variables to one side. So get rid of the variable on the right using opposite operations. So get rid of the variable on the right. By using opposite operations. Alright, so looking at example 7, I have two variables. Well, what we just said, we have to get rid of the one on the right side and bring it over everything to the left. So, to bring that x value over, I'm going to go ahead and, since that is a positive x, I'm going to subtract x over to the other side. And I'm going to place it under its like term. So that's why you see me write the x under the 3x, because I know that the two terms I'm going to combine. I would not put it under the 20 because I can't combine 20 minus x. Alright, so simplify this. 3x minus x is 2x. I still have my plus 20 there. Bring over my equal sign. X minus x is 0, but I do still have a negative 8. So now that gives me my one variable on the left side, but I still need to isolate it. And again, going back to addition and subtraction, I have to move over that 20 to the right side. Since I'm adding 20, I'm going to subtract 20. Because whatever I do to one side, I have to do to the other side. So I have 2x equals 20 minus 20 is 0. Negative 8 minus 20 is a negative 28. My x is still not isolated. I'm currently multiplying 2 times x, so the opposite of multiplying by 2 is dividing by 2. Whatever I do to one side, I must do the other side. So therefore, I have 1x equaling a negative 14. Never really see that coefficient of a 1. So therefore, my final answer is x equaling negative 14. Alright, final example here for this video. I have to bring over my one variable that's on the right side to combine it with the one that is on the left. So if I am subtracting x, the opposite is adding x over to the other side. Combining like terms, I have a negative 7x plus x, which gives me a negative 6x plus 11. Don't forget my equal sign there. 19, and negative x plus x is 0. Still have to isolate that variable, so going back to my addition and subtraction. If I'm adding 11, I have to do the opposite operation, which is subtract 11. Whatever I do to one side, you have to do it to the other side. So on my left side, I have negative 6x equaling 19 minus 11 is 8. If I am multiplying negative 6 times x, the opposite of multiplication is division. And whatever I do to one side, I have to do to the other side. Negative 6 divided by negative 6 is 1. So my final answer here is going to be x equaling 8 divided by negative 6, which is always simplify our fractions here. So negative 4 over 3. Alright, that brings us to the end of the video, so you can go ahead and work on activity 1B.1.